interested in getting a new bike. And even though I love my bike, I'd like to get a bigger wheel because I have a 650 wheel and I'd like to upgrade it to a 700 wheel. And if I'm going to do that, I may as well look at other things I can upgrade. And apparently Harry does a great job sizing people, so I think he's going to be a good shop to check out. So this is my machine.
We're going to do bike today?
Yeah, I want you to take a look at this and tell me what could be improved.
My passion for building the best road bikes money can buy started in 1976. For 18 years, I worked in the family bike business with my father, who was a former six-day race mechanic, and my brother, who was a Pennsylvania state time trial champion. I became a bike racer myself and wanted to incorporate ideas I had into a superior product. Since 1976, I have been perfecting the art of frame building using hand tools, welding fixtures, lathes, and tube bending machines. We do everything here except the painting. We buy the raw materials, including tubes and fittings, to hold the wheels, cables, crank, and head bearings. Then we cut the tubes to length, jig them up on a flat surface to hold them straight, and tack weld them. Then we do the final welding. Besides me, the team includes Dennis Tate, who does a lot of the hand and finish work on the frames, our welder Ed, and Drayton, who hangs the components on each frame to complete the bike. The componentry includes gears, shifters, wheels, seat, chain, handlebars, brakes, computer, and even water bottles. Custom frame building begins with an interview. We ask the customer about previous bikes they've owned, riding style, what they want to do with the bike, any special physical limitations or needs, and budget. Prices range widely depending on the materials used and the quality of the components. For a complete bike that we build, prices can go from $1,700 to $12,000 for a bike we built for the 2004 Olympics. What we do is for every bike that we build, we generate a blueprint. This plan gives us all the dimensions, angles, basically all the information that we need to build the bike. Now the plan is generated based on the interview process that we do with the customer. The bike itself is broken up into a front and a back half, and we basically get the two halves, put them together, and then we have a finished product. Materials account for a lot of the cost. We make a lot of bikes using chromoly tubing, which is steel with chromium and molybdenum added to give the steel desired characteristics, including controlling something called grain growth. Grain is a molecular structure in the steel, and when you heat it up for welding, metal grain can clump together, making it weaker. To offset grain growth, steel makers add other elements to keep the grain small. We design bikes using steel, titanium, aluminum, metal matrix composite, and carbon fiber, depending on needs discovered during this interview process. Sometimes we go with a tube that's larger in diameter, or with a little thicker wall, to accommodate the weight of the rider. Sometimes we ovalize the ends of the tube to provide stiffness in certain directions. First thing I want to check in the process is let me have you throw your leg over the bike and stand over that top bar. Now if you were to lift the seat and the handlebar, just lift the bike straight up underneath you. How much room do you think you have in there?
Probably an inch.
About an inch?
Mm-hmm.
Okay. All right, you can jump off.
Okay.
In designing a custom-made bike, there are two aspects we work on. One is getting the bike to feel the way the customer wants. The other is getting the right fit. Choice of design and materials takes care of feel. To get proper fit, we listen and look. First, we listen to the customer tell us about their current bike. They bring it in and they show us what they like and what they don't like. Then they sit on it. We look at how their feet are situated on the pedals. We see how the knees are in relation to the pedals. We look at how much the customer leans over. We look at the arms when they hold the handlebars, looking for problems with possible constricted breathing, and so on. For general road riding, you want to be right over or just behind a little bit. Our unique contribution is that we customize. We design based on the bill of particulars each customer orders, and that's the difference between us and major manufacturers. Having trimmed all our tubes down to length, now it's time to actually put a miter in. And the miter is the circular cut that will allow one piece of tube to lay up against the other tube. Now, the issue with a miter is that you want the miter to be centered over the tube this way. You don't want it to be off to one side or the other. If it is, when it matches up, your tube's going to be shifted, which you don't want it. Your bike will be crooked. Now, the second issue with a miter is the angle that it makes to the other tube. You want that angle to be very specific according to your plan. Putting the first miter in is relatively easy. You set it up in a machine, we're going to chop through it, it's mitered. The problem is when you go to put the miter at this end of the tube, you then have to get exactly the right length from the center of this tube to the center of this tube. The miters have to be obviously the right radius, the right length, the right angle between the two miters, and then there's something known as being in phase. And what that means is that you want this tube up front, the head tube, and the seat tube that's back here, you want so that when you look down, they're exactly parallel. You didn't want this tube twisted this way. So in order to achieve all that, it's tricky. Putting our first miter in, see, it's starting to look like a bike already. We fit our tube back into the machine, located up against the dummy plug here. All right, here we go. So that when we put the head tube in place here, and we put the seat tube in place here, you can see it's starting to look like a bike already. This machine is fixtured so that it miters both seat stays at the same time. Okay, what we just did there was miter the two tips here, so when this all comes together, you can see that it kind of forms a cradle in here where your seat tube will fit right through it. What we're going to be doing here is removing the burrs from when we mitered the tubes. When the cutter goes through the tube, some of the material gets pushed in the form of a real sharp burr, so we're going to be sanding it off. And you can see here what those burrs look like. Also, when you get a paper-thin edge like this, if you go to weld that, that's just going to burn away. There's not enough meat there to weld onto. So all that gets sanded back to a point that you have enough material to weld on. That's what we're looking like right there. Now that needs a little bit more handwork to get off, even just a little bit more of the real fine, but that's pretty good. So what we're going to do now is we're going to actually load the fixture up. Now this frame that we're doing is a titanium frame. It's going to get TIG welded. TIG stands for tungsten inert gas, which is a type of welding process that we'll talk about later. This piece is the bottom bracket shell, which is the portion that houses the crank. Now you'll notice when I'm handling these tubes, I'm touching them by the middle sections of the tubes, and that's because the ends have been sanded to get off any kind of mill scale or oxides that formed during the making of the tube. There we go. That's all clamped in place. We just have to hold a few things while Ed comes in and does the tack welding. Earlier, all that time that we spent putting in very accurate mitering, and like I really stressed how important it was to put all that care into it. Here's the payoff. If you look in here now, you can see that there are no gaps all the way around here, all the way around here. These are near perfect miters. I say near perfect because there's always room for improvement, but this is as good as it gets. It's beautiful. Everything's nice and tight. You can't really appreciate this on a bike that's already been built, because once the weld bead goes down, it hides a multitude of sin, and there's no telling how it was constructed underneath that. When you have one tube that touches another tube, like in this case, all the way around, it makes a much tighter, stronger weld joint than if you have gaps that have to get filled with the weld wire. Should be it. There you go. It looks like a bike frame, and when Ed's done welding it, it'll be a bike frame. What we're going to do here is miter this chainstay bridge, which is what it'll eventually become, to fit inside here. We currently have the same problem we've had with every other tube where it meets another tube, and that is it doesn't fit. So what we have to do is measure the angle between the tubes. We already know what the diameter is, and we get the appropriate cutter, set the milling machine up accordingly, and we'll miter this so that it fits exactly where it has to. Okay, now that the piece is all mitered up, with a little luck, this will fit in, a little pressure, and you can see how the miters are absolutely perfect. Everything lines up. There's no gaps anywhere. So that's ready to get welded in. Once we determine the materials and fit for a customer, we choose among 3 different methods to build our bikes. The first is the most traditional way of making high-quality bike frames, and that's through a technique known as lugged and brazed frames. Simply put, a lug is a socket. A tube fits into it, and then you heat it up with a torch, feed in either silver or brass brazing wire, and as it melts, it flows between the tube and the lug, creating the joint. We use silver to braze instead of brass because its lower temperature minimizes grain growth, resulting in higher strength. Silver melts at roughly 1,050 degrees Fahrenheit, while brass brazing takes place between 17 and 1,800 degrees Fahrenheit. So we can control grain growth by using 80% lower temperatures. That makes a huge difference. What we're doing here is the flux has already been washed off. We have a bare frame. The lugs have casting marks in them. When the 2 halves of the mold came together, there's something known as a parting line, which is when the 2 halves open up, you can see the seam. So those seams are running, there's one up in here, it goes through the lug this way and down the front. So there's an irregularity. Also, right in here, there's a mark that's cast into the lug telling us the degrees that the lug makes. So all that has to get sanded off. But most importantly, Dennis is going to be going in there and he's going to be filing down the braze material that goes through here. Depending on how he thins those lugs down, will actually alter the way this frame flexes when you hit bumps. The general rule of thumb, it's kind of a joke, but it actually holds. So what he does here is he files and sands away everything that doesn't look like a bike. That's the 2 head lugs, all finished up. He'll do that on the seat lug, the bottom bracket, the rear dropouts, every place that we just brazed up. We'll get that same exact treatment. Now, if you notice, everything has been cleaned up except for this surface right here. And what will happen is, when this frame goes to the machining aspect, there's a reamer that goes in and will verify that that tube is round, like there's no distortion. And also, it'll face it off this way so that it's flat. So when you press in your tube bearings, everything is sitting concentric with the head tube, and also the 2 surfaces here are parallel. After this gets machined, it'll leave like a burr or a sharp edge around here. So the frame will come back to this station, and Dennis will sand that off again, making everything smooth again. Down in there, but everything is once again perfectly round, and it's perfectly flat this way. The second technique is called TIG welding and involves an electric welding process. TIG stands for tungsten inert gas. In this process, a tungsten electrode is used to heat steel or some other material to over 2300 degrees Fahrenheit in the weld area. We use a foot pedal to control this temperature. TIG welding is a high temperature process, and we use different steel tubing from what we would use if we were building a lugged frame. Even though TIG welding is done at a higher temperature, it's a quicker process than brazing, resulting in fewer calories of heat being used. In TIG welding, there is no lug or socket. Instead, one tube lies up against another, and we weld the junction where they touch. If the tubes are chrome moly steel, then we use chrome moly weld wire. For a titanium frame, we use weld wire that matches exactly the titanium alloy of the tubes. We do it that way to preserve the peak strength of the materials. The third method uses glue on a lugged frame, but uses a deeper lug than on lugged and brazed frames. In a glued frame, we cut the tubes, smear glue on the ends, and inside each lug, push them together, and use a fixture to hold the frame still for 24 hours until the glue hardens. The advantage of a glued frame is that there's absolutely no heat involved, so we don't change the grain one bit. Another advantage is that we can make frames out of materials that are unweldable, like carbon fiber, metal matrix composites, and mixtures of materials, which is another advantage of this process. The last step in bike design is the selection of componentry. Here, you can go with the artful, passionate side of cycling, or the scientific, technical side. If you want technical and mechanical perfection, you might want to look at the Shimano line. If you want art, I suggest Campagnolo.
This here is a Shimano bottom bracket. It's a spline bottom bracket. Goes with the Shimano 105 cranks. And these are the STI integrated shift levers. These are called dual pivot arch brakes, very strong brakes. Then we have a 9-speed cassette, which are the gears, rear derailleur, and your front derailleur. Michelin tires, and they're real nice tires. Other components, brake and gear cables with housing. Chinelli bar tape, it's nice. 2 inner tubes, long stem valves, and your rim strips to cover the spoke nipples. Reynolds carbon fork, aluminum stair tube, carbon blades, aluminum dropouts. A set of Mavic wheels here, really nice wheels. Here we have one of our aluminum frames that I'll be building up today. First grab the seat post. Let's get this nice and looped up with PACs. I'll start installing the bottom bracket cups. it nice and snug. Okay, get it nice and snug. We're going to install the rim strip. Chain tool, professional tool, really nice tool. Okay, these are the headset press cups, which I'll be using to press these headset cups into the frame. And I will need a Campy headset press tool. This right here. For installation of the fork, cram race on. Bearing. Top bearing. Okay, fork is installed. Alright, solid.
One of our greatest strengths is serving customers with special needs. A lot of our customers can't go anywhere to get a bike. Many are either too big or too small or have unique physical limitations. We have the ability to fit the non-mainstream customer.
My name is Jennifer Adams. I'm 25 years old and I am currently in law school. Because of my condition, I'm not able to run, but I'm physical and I've always liked sports and I like being in shape, and biking was a way for me to really stay in shape. About a year or so ago, after I'd gone through a couple of bikes, I realized I was going to need something that was meant for some serious riding. I was going to need more of a road bike, but they don't make road bikes in the size that I would need. So I realized that I was going to need something made for me, something custom. So I was riding every day, 7 days a week, on bikes that were meant mainly for children. You know, they weren't meant to take the wear and tear of serious riding. So I was getting a little bit frustrated with that, and I was realizing that I was going to need something more for an adult. But they don't make bikes like that for someone my size. I did some research and got some names and went and met Harry and went and saw his I don't know if you would call it workshop. It seems more bigger than that. But saw where he makes bikes and saw his whole operation there, and talked with him and spoke with him about my needs and what I wanted and how he would be able to help me. And so a few months later, we made arrangements for him to make a bike for me, and he took my measurements and so that he could really make it custom, and it fit me perfectly. I mean, and it's been great. It's such a wonderful service that he provides. I mean, I feel like I owe him so much, but just he's made a dream come true for me, so it's been great.
In terms of where we're taking the company in the next 5 to 10 years, we want to get our bikes into other shops. Currently, if you want one of our bikes, you have to come to media. We size you up and build the bike, and if it's a custom, you pick it up in a couple of weeks. If it's one of our stock bikes, you could leave with it in a day or two. Our stock bikes are made to the same high quality level as the customs, but are made to pre-selected sizes. What that means is that the miters, welding, machining, hand finishing, and alignment are identical and to the highest levels of precision. So that if you're in a bike shop in California and want a bike by the weekend, we can ship out the frame, they can assemble it into the finished bike. That's what we want to do next, get our bikes into shops throughout the country.